Hey, welcome to chapter 3. In chapter 3, this is where we describe the relationship. So we went from having one variable, one quantitative variable, to two quantitative variables. And this is where we looked at scatter plots, least squares regression lines, all of that stuff. So here's the deal. In section 3.1, we started off by talking about what is the explanatory variable, what is the response variable. So the explanatory variable is, in essence, your independent variable. Your response variable is your dependent variable. So explanatory is your x, response is your y. If I could flip the page, here we go. So part of it was just read a passage to determine which is which. Then we took a look at, all right, how are we going to actually describe or display this relationship between two quantitative variables? And the way that we do that is with a scatter plot. And the scatter plot shows the relationship between two quantitative variables measured on the same person. So I might take an individual's height and their arm span, and another individual's height and arm span, and I would be graphing these data points on a scatter plot. Okay, make sure you label your axes. It has to be two quantitative variables measured on the same individual. All right. So then we got into describing scatter plots. And the acronym that I gave you for this was simply DOFS, where the D stood for direction. You could have a positive, negative, or no direction. The O was for outliers. Do you have any outliers, yes or no, or potential? F was for form, and the form could be linear or non-linear. And S was for strength. And we could have moderate, strong, or weak. And I encourage you to use LY words here, like moderately strong, moderately weak. It gives you a little more flexibility as opposed to just committing to something and having a higher likelihood of being incorrect. So that's how you're describing a scatter plot. So in this scatter plot, I would describe there is a positive, moderately strong linear association between points per game and wins, including context in there at least once. I don't see any outliers, so I wouldn't mention that. Okay, you could do that all in about 2 sentences. You don't need to draw it out, but you can. All right, so positive negative association, that should be pretty self-explanatory. Okay. Then we got into how do we actually measure the strength. And what we did is we used the correlation to measure the strength. And they show a few different scatter plots here as far as determining if the strength is positive. The closer it is to +1, the stronger positive linear association there is. Closer to -1, same thing. All right. What is this talking about? Interpreting correlations. So if you're asked to interpret the correlation, it's just the strength and the direction of the linear form. So if my correlation is 0.9 between height and arm span, then there's a strong positive linear association between height and arm span. In general, as one goes up, the other goes up. Okay, facts about correlation. Yes, this is good stuff. Okay, so correlation is denoted by lowercase r. And the way that we talk about correlation is this. Correlation has no units. It's just a measure of strength. It has no units whatsoever. Switching the x and the y variables does not change the correlation. Keeps it the same. The amount of variability between the data points has not changed. We talked about that. Correlation is not resistant to outliers. Like mean and standard deviation, it is not resistant to outliers. And the very, 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 very important one is this. Correlation does not imply causation. you can have two variables that are highly correlated. That does not mean one caused the other. As we know from chapter 4, like you have to have a controlled, randomized, replicated experiment in order to conclude cause and effect. So correlation does not prove causation. All right, so quick summary. We do a scatter plot when we have two quantitative variables and we want to see if there's an association. One is the explanatory or independent variable. The other is the response of the dependent. When we're describing the scatter plot, we use DOFs, direction, form, strength, outliers. And then we're going to measure the strength with the correlation. Closer to positive or negative 1, stronger, closer to 0, we get towards no linear relationship at all. All right, that's section 3.1.